Hello everyone and welcome back to the C++ 3D game tutorial series. In this 34th video tutorial, we will see how to create and manage the mesh components. In particular, we will see how to design and implement the mesh component class, how to handle the mesh components through the graphics engine, and in the end, we will see how to easily create and handle graphics entities in our game class. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to create and manage the mesh components. Let's start with the requirements. We need a C++ IDE. In this series we use Visual Studio 2019 Community. The target platform is Windows. The target graphics API is DirectX 11. And last but not least, a bit of knowledge of the C++ programming language is recommended. Now we can start the design part. The last time we have seen how to create and integrate component classes in our entities and how to create the transform component. Today we will see how to create the mesh component class to show and manage 3D objects on the screen. Let's start by adding the mesh component class in our entity package. Obviously, let's inherit the component class. The mesh component class should handle two main resources: the mesh resource and a list of material resources. The list of materials is necessary to provide all the necessary shaders to render all the parts of a specific mesh. For example, in the previous tutorials, we have rendered this mesh house by providing 4 different materials: one for the brick, one for the windows, one for the wood, and the last one for the barrels. As usual, let's add the setter and getter for our attributes. Through these methods, the management of complex meshes like our house will be simplified a lot, like in this example. At this point, once we have created the mesh component class, what do we have to do? We need to exploit the data stored in the mesh components to render the meshes on the screen. To do that, we will exploit the graphics engine class. The goal is to aggregate all the mesh components in the graphics engine class and, in the update function, loop over these components, retrieve the meshes and materials inside them, and render them on the screen. As usual, we will deepen this aspect in the implementation part. If you have questions, doubts, or comments about this topic, don't hesitate to leave them in the comment section of this video or in the Discord server. The link to the Discord server is available in the video description. Also, if you find these tutorials helpful, please consider to support their development on Patreon. Every single contribution makes the difference, regardless the amount. Very well, we have gathered all the necessary information to start the implementation. As first thing, let's create the mesh component class in the entity package. As usual, let's add the constructor and destructor methods. As we have seen in the introduction, let's add the attributes. Let's start with the mesh attribute of type mesh pointer. This attribute will provide the necessary data to render a 3D object on the screen. Let's add the usual setter and getter methods. At this point, let's add a vector of material pointers. The list of materials is necessary to provide all the necessary shaders to render all the parts of a specific mesh. As first thing, let's add two methods, add material and remove material. For these methods, we can respectively add and remove materials to and from the list. In the end, let's add the getter method. Remember to return const reference to the vector in such a way to avoid to create a useless copy of the vector. In general, the mesh component is ready. Let's go to the graphics engine header file, and here let's start to add a set of mesh components pointers. Let's call it meshes. Don't forget to add a forward declaration to mesh component class in the prerequisites header file. At this point, we have to add two important methods, add component and remove component methods. Through these methods, we will be able to add any kind of components we want to the graphics engine. Let's implement them. Obviously, the graphics engine needs only some types of components, especially the graphics ones like the mesh component. In order to identify the components of type mesh component, we have to use the dynamic cast operator. If the component passed as parameter is a mesh component, let's add it in the set of meshes. Let's do the same thing for both the add and remove methods. Now a question comes spontaneously. How can we add the mesh components to the graphics engine? Let's go to the component class and let's add an onCreate internal callback method. This method should be called at the creation of the component. Let's go to the entity C++ file and in the create component internal method, let's call this method at the very end. In this way we can handle private stuff at the creation for the components that need it. In particular, let's override the onCreate internal method in the mesh component class. And here we should retrieve the graphics engine and call its addComponent method. We have to pass a reference to the game instance in the world class. Let's also add a getGame method. Obviously, let's remove the component from the graphics engine when the destructor is called. So far, so good. What's next? Well, we have to loop over the set of mesh components and render them on the screen. Let's do this in the update function. What do we have to do here? We should get the transform component of the entity in which this current mesh component is placed and get its word matrix. So let's go to the component class and let's add a getEntity method. The only thing that we have to do is to call the getWordMatrix method of the transform component class and pass the word matrix of the constant data structure as parameter. Now that we have the global transformation of this specific mesh, let's retrieve the two most important resources, the mesh and the materials. The rendering code remains practically the same. We have only to check if the number of material slots of the mesh doesn't exceed the current number of materials added in the mesh component. In this way we can render the mesh even partially if some materials aren't available. In the end, let's remove the old temporary parameter of the update function. At this point, let's go to the game C++ file And in the onUpdate method, let's remove the object passed as parameter to the update function of the graphics engine class. The only thing that remains to do is to remove the code in the onCreate method related to the loading of resources and add it to the onCreate method of our own MyGame class. There are a lot of things to fix. As a first thing, let's go to the game header file and let's remove the old attributes. Then let's start to add the getResourceManager method. Also, don't forget to pass the pointer to the game instance as parameter to the world constructor. Let's turn back to MyGame class and let's fix the code by using the getResourceManager method. Let's include the header files of Resource Manager and all the various resource classes in the all header file. The last thing to do is to finally start to create a graphics entity. So let's add a mesh component. As usual, let's include the mesh component header file in the old header file. And let's set the mesh we want to render. Let's also add a material. We have to fix an important thing in the matrix class. Let's initialize our matrix with the identity matrix. Let's put a breakpoint in the onCreate method and let's start to debug our game. The creation of components seems okay. Even the passage of mesh components to the graphics engine seems to work fine. Let's see if the update function of graphics engine class works as well. And it works! We don't see the entire mesh because the mesh is composed by 4 material slots and we have provided only one material. Let's fill the remaining material slots with the same material. And it works! As last thing, let's transform our entity a little bit. In particular, let's rotate our house of 90 degrees each second, along the y-axis. That's all for now, folks. Today we have seen how to create the mesh component and to finally handle graphics objects easily through our entity component based system. The next time we will finally create a simple 3D level. I hope you enjoyed this video. See you soon. Thanks for watching.